Hello, guys. Today we are going to talk about this mathematical concept, which is a unit called second and higher order differential equations. And first subtopic will be higher order differential equations. Okay, here consider nth order linear differential equation in the form of y power n, that's the nth order, yeah. So this is an nth order linear differential equation. For this to be a linear homogeneous differential equation, that means the value of Rx should be 0. That means this here is nonlinear, but if value of Rx is equal to 0, then this equation will be called linear homogeneous differential equation, whereby a1, a2, and an are constant, which may be real or complex function of y. Complex function of y. Now, using the linear differential operator, this equation can be written as, okay, using the linear differential operator, that is L into D. The equation can be written as so we can say yes. Now, replacing D with M, that is Now this equation, call it star, and this star equation, it is called the auxiliary equation of the differential equation. Auxiliary equation of the differential equation. Yeah. So right now this is introduction to higher order differential equations, who is nth order. So now we're going to see the cases of homogeneous linear differential equation and how we can solve them. So generally we have three cases. So how we're going to see the cases, we're going to see them. Subtopic is cases of homogeneous linear so we have case 1. Case 1, when all roots are real and distinct. This is all roots are real and distinct. That means the equation we said earlier, LM is equal to 0, which has n roots, that is M1, M2 and Mn. How is the solution? The solution will be y of x is equal to c1 e power m1x plus c2 this will be the solution, and we are going to see examples on it also. So let's study the cases first, then we'll go for case 2. So for case 2, this happens when roots are real and repeated. So roots are real and repeated. The solution here will be c1 plus c2x plus c3x squared plus c4x cubed. This is the solution for case 2. Then on our last case, that is case 3, when the roots are complex function. It is m1 2 is equal to what the solution will be. Solution will be y So these are the three cases and their solutions. So we are going to see examples of it. So, and as explained, how to know linear if the equation is homogeneous or non-homogeneous. Example we're going to show here by studying this concept here. Homogeneous linear differential equation of second order. That means here d square y plus this is the linear equation of second order, and it's homogeneous if the value of Rx is equal to 0. So here this is non-homogeneous. So this is homogeneous, and if is equal to 0, this will be called homogeneous equation. Likewise, this equation can also be written in this form. P of x this will be non-homogeneous, and if is equal to 0, this will be homogeneous equation. So the next thing we're going to look about the type of equation. I'll group the equations and their types. So for this, I'll make a table saying equations, and here I'll put type. So example of this equation is this equation is a linear homogeneous dA differential equation with constant coefficients. With constant coefficient 2 and 1 and 1, all are constant coefficients. Then we have another type of equation which can be in form of 1 minus x square minus 2xy plus 6y is equal to 0. So this is a linear homogeneous differential equation, but with variable coefficients. So it is linear homogeneous differential equation, but with variable coefficients, because the coefficient of this one here, it is 1 minus x square, so it depends on the value of x, so it's a variable. Another form of equation is plus 6y is equal to a power x. Because of this will be a non-homogeneous linear non-homogeneous differential equation, but with constant coefficients. So we can say linear non-homogeneous differential equation with constant coefficients. Then we have another x square plus y is equal to sine of x. Because of this will be a non-homogeneous, so it will be linear non-homogeneous differential equation. But because the variable also depends on value of x, so it will be a linear non-homogeneous linear non-homogeneous differential equation with variable coefficients. You can say linear non-homogeneous differential equation with variable coefficient. Then we have another form of equation is y this equation will be non-linear because of this. Just the degree will increase here, so it will be non-linear equation. Yeah. So here the introduction to the topic is done. Then we'll go to another unit, which is homogeneous equation with constant coefficient. We already seen them from the previous table. With constant coefficient. So consider an equation what will be the auxiliary equation of the differential equation, that is replacing y with m. We are replacing y with m and normal y with 1. So here will be m square plus am plus b is equal to 0. Yeah, so from this equation now we'll have the three cases which we saw earlier. We'll go to pass through them again for the last time. That means we have case 1, roots can be real and distinct, that is m1 and m2. And what will be the general solution? In this case, we say that solution will be y is equal to c1e power of m1x plus c2e power of m2x. Then for case 2, that means roots are real and repeated. That means m1 is equal to m2 is equal to m, and the solution will be y is equal to c1 plus c2x e to the power of mx. Then we'll have the last case when the roots are complex roots. That is m is equal to and the solution will be is equal to e power c1 cos beta x plus sin beta x. I think right now the introduction is done. We can solve a few examples for case 1, case 2 and case 3, and on the next video I will make a separate video solving more and more examples. So now we'll do each case one example, and on the next video we'll do the next examples. Will be having the particular solution. Right now we'll do the question with the only the general solutions. So let's go. Example 1. Solve solution. So the auxiliary equation AE will be m square minus m minus 6 is equal to 0. So I need to find the roots. Using factorization, we can factorize it. M square minus 3m plus 2m minus 6 is equal to 0. We can say m minus 3 plus 2 m minus 3 is equal to 0. M minus 3 and m plus 2 both equal to 0. So m is equal to 3 and minus 2. This is a case 1 scenario where the roots are real and distinct. So solution will be c1 e power 3x plus c2 e power minus 2x. And this is the equation. And then we'll go to solve example 2. Solve y minus 6y dash plus 9y is equal to 0. Same steps. Auxiliary equation is equal to m square minus 6m plus 9 is equal to 0. This can be m plus 3 square is equal to 0. This is not m plus 3. This is m minus 3 square. So m minus 3 and m minus 3 is equal to 0. So m is equal to 3 and 3. And this will be direct as case 2, whereby the roots of the equation are real and repeated. So what will be our solution? Will be c1 plus c2x bracket e power 3x, and this will be done. Now we go for example 3. Say solve y double dash plus 9y is equal to 0. AE is equal to m square plus 9m is equal to 0. M square is equal to minus, no, There's a mistake. This is m square plus 9. So m square is equal to minus 9. M is equal to this. And that's your m will be positive or negative 3i. So the root will be a complex function. And what will be our solution? Y is equal to e power x c1 cos 3 plus c2 sin 3.